is a handout solution to problem 1. I will now explain the pinch analysis table. You can check it out. It requires patience to get a correct answer. Now, you turn it over. Let's do it together. How do you create a network? Too big, too big. You see. What happened? Okay, let's take a look at this problem. This is Hausdorff 1, Hausdorff 2, close to 1. The first step, you draw the pinch line. 480 for hot, 460 for cold. And at minimum, above the pinch. Above the pinch, we do not see any hot stream. We see one cold stream. Above the pinch, process is cold. You only need heating utility, no cooling utility. So, one happens to be the heater. So, this easy, H1. You check it out. Capacity flow rate 11530 BTU per hour per degree F. Time 40 degree temperature rise. That happens to be QHV. Below the pinch, and me. Below the pinch process is hot. cooling utility. Below the pinch, we see two hot streams, two cold streams. You do not need heating utility, only cooling utility, -1. 4, there could be 3 exchanger, 1 cooler. Remember on Friday, we emphasize if your steam is the highest hot stream temperature, cooling water going from 80 to 180 degree F represent the lowest temperature cold stream. Then your heater should be on the highest temperature portion of cold stream. That's what we did. How about cooler? Should be on the low temperature portion of hot stream. We want to put 1 cooler in the lowest temperature portion of hot stream. So capacity flow rate, this is 251.74. That heat duty, this area equal QC mean. So always put cooler, giving you the lowest average block temperature. Heater at the highest block temperature. This is the average. Any question? Now, below the pinch, we need to put 2 more exchanger. Hot stream below the pinch, you have 2 blocks. Cold stream 2 blocks. 3 exchanger. You need to check 2 things. 1, temperature for delta T mean, 20 degree F. 2, heat duty. So the first thing we do, what is this area? 4 milli BTU per hour. This 251.74. This 1137.676. How about the bottom? You calculate them. So you check on the hot side and cold side. The sum, 676,600 is okay. Close enough. So now the next question, you look at here, 320, you want to take care of this block. You cannot match the 2 because those 2 are identical. How about this one? 480, 460, that's good. Now, 2536600, this area, you cannot match those 2 either. 220 below 460, right? So H1 cannot match with C1 or C2. Now, later on, after you make change, you made. Now you cannot match because 320 degree equal 320 or less than 460. This is C2, C1. Do you get it? So, we cannot do that. 480, so let's put this on the top. Call this E1 351.17 degree F. E1. This is 2536600 BTU per hour. How do you determine that? Temperature drop times capacity flow rate equal heat duty. Right? Temperature drop times capacity flow rate equal heat duty. E1. So, what's remaining here? 1463400 BTU per hour. 351. This one is done. It's higher than 320. 320 equal 320. We said before, H1 for now, it cannot match with this. So, I put E2 here, 351 is greater than 320. E2, what is this area? 1463400 from here. And what is this temperature? 218.73 degree F. How do you know that? Temperature difference times capacity flow rate equal the area. Now, 220 is greater than 218. It's okay to match that. 256 is greater than 140. Right? And these two areas equal, this area is 1137676. Any question? Easy one. You need to do more problem. Yes. What's your question?
Since we're away from the patient,
What did you say? What are you saying? What's your question?
so since we're away from the pinch point, do we have to consider the capacity flow rate out greater than in?
No, that only applies to pinch point itself, not away from pinch point. Okay? That's at the pinch point. I think the pinch point, the capacity flow rate rule, sometimes people misuse it. They think they can apply to away from pinch point. No. And main temperature difference, heat duty. Okay? Now, look at down here. So, you have a pinch point, C1, 240 to 500. This is 460, is 480, 500. C2, 140 to 220. H2 below the pinch, 480 to 280. H1, 220 to 200. Above the pinch, we put a cooler. There's no other option, right? Below the pinch, we need to actually a changer, one cooler, and this happens to be the low temperature portion of hot stream compared to 280, right? This is 280, this is 200. So, I put a cooler here. That gives you this temperature, 251.74. Put two more exchanger. And this, 480, 460. You match from high temperature downward. C1, just stop at C1. You put E1 here, E1, 460 to 240. Here, 480, 251.17. E1, fully taken care of C1. What's remaining, this portion, that is this area, right? You look at it, 353, above 220, this side is okay. So, we can fully cool down this hot stream, E2, 251 E2. This is 280, right? This is 280. 280. 351.17 to 280. E2, 218. 218, that is here, 218. The remaining one is this portion. That is this exchanger. I'm biased. I prefer to see this heat content diagram, can visualize the whole thing. This one, you give a bit more problem, then you can apply this faster. Right now, you need to do it step by step. Okay? That is homework problem 1. Now, I want to go through another example, beginning page 59. I emailed you last Thursday, copy of page 59, 60. We did this problem before in terms of utility target. What's special about this problem? introduce to you the new concept, splitting a stream. When one hot stream exchanges heat with two cold streams, you need to split the hot stream. Here there's a problem, two cold stream, two hot stream, given capacity flow rate, kilowatt degree C. We did this before in terms of heat duty. Too big. I don't know what happened. Clean up, make it smaller. Uh-oh. Hmm? Uh-oh. Okay. Hmm. Too big. Can I make it smaller? Higher a little bit. That's good. All right. This problem, we did it before. Hot stream pinch, 150. Cold stream pinch, 140. QH mean 60. QC mean minus 160. 60, 160. Have another repeaters. So, let's begin learning. How do we match the stream on page 61? Steam has the highest temperature, cooling water temperature. First, hot stream pinch is 150. Cold stream pinch, 140. So, above the pinch, one hot, one cold. Above the pinch, plus is cold. You need heating utility, no cooling utility, minus 1. 2. 1 exchanger, 1 heater. Below the pinch, process is hot. Okay, below the pinch we see too hot, too cold. You do not need heating utility, you only need cooling utility. 4. You could have 3 exchanger, 1 cooler, or 2 exchanger, 2 cooler. So let's start above the pinch. This 3 kilowatt times 40, 120 kilowatt. Here's 160, 20 degree, no, 150. 150, 30 times 2, 60 kilowatt. You normally apply steam heating at the highest temperature portion of cold stream. So H, 60 kilowatt, 160 degree. QH mean 60 kilowatt, QC mean 160 kilowatt. Then E1, 180, 160, 150, 140. Delta T mean is 10 degrees C. 150 exactly 10 degree above 140 is feasible. Below the pinch, 140, 60, so 80, this is 240 kilowatt. Two 150, 40, 220 kilowatt. This 110, 440 kilowatt. Here is 260 kilowatt. Now let's ask. Closing 1, exchange heat with H1 or with H2. First, 240 is larger than 220 if you exchange heat. You create a tiny exchanger down the bottom. That will make it difficult to reach the end mean target. That's one. The other thing is, notice 40 is smaller than 60. You draw a temperature profile, 150 to 40. That is your H1. 60 to 140. 60 to 140. That is your C1. That creates a temperature crossover. Infeasible. The other thing is 220 kilowatt is smaller than 240 kilowatt, creating a small exchanger. This exchanger is extra. So, C1 with possibilities out. I put E2 here. I put E2 here. That will stop at 90 degrees. 60 times 4, 240 kilowatt. E2. Now, what's remaining? Let's look at it. This is 260. This, what's remaining is 90, 40, 50 degrees. So we have 200 kilowatt remaining here. 220, 420, 260. You see, 420, that is the sum of the two. Minus 260, 160 kilowatt. That happens to be QC mean. Where do you put QC? Cooler. I could put cooler here. 160 kilowatt. This is 80 degrees. It's 90 degrees. Why do I put cooler here instead of there? Let's take a look. H1, H2, 4 kilowatt per degree C, 2 kilowatt per degree C. You want to put 160 kilowatt here. That is 40 to 80 degrees. You want to put 160 kilowatt here, and you need to go 40 plus 80 degree temperature rise, 120. Now, which one represents more efficient use of the lowest temperature cooling water? This average is 60. This average is 80. You want to choose to put the cooler giving you the lowest average block temperature. 60 is lower than 80. Why lowest block temperature? Because cooling water is the lowest temperature cold stream. So, I put cooler here. Now, what's remaining? 260 kilowatt. This is 40 kilowatt. This is 220 kilowatt. This is 260 kilowatt. Right? How do you match one cold stream with two hot streams? You need to spread them vertically. What does that mean? You may have a C2 coming in, 30 degrees. You want to split it into two portions. Okay? One, you want to exchange with H2. The other, you want to exchange with H1. This one is 40 kilowatt. This one is 220 kilowatt. And total 260, right? So, you can put E3 here, E4 here, E3, E4. Now, you worry about temperature difference last, okay? First, you need to split this, so this portion, this is 220 kilowatt, right? 2.2, 220 over 260 times 2.6 kilowatt per degree C. So essentially this is 2.2 and this is 0.4. In terms of capacity flow rate, 0.4 kilowatt degree C, 2.2 kilowatt degree C. This E3, E4. Now, at the very last, we check if the change is feasible in terms of temperature. 150 above 130, 40 above 30. E3 is okay. E4, troublesome. 80 above 30, good. 90 below 130, questionable. Don't give up. If you have one delta TB violation, you apply the same trick. How? Let's draw the top. E2, E4, 90, 80, 150, right? 150, 80. Split it. Now you check. E2, 150, 140, 80, 60. E4, 150, 130, 80, 30. Good. So, at the last, it changes to a vertical line. Split that part. How about that? Distance. This distance. Okay. What is this? What is that? This whole thing is 4 kilowatt per degree C times 240 over 280. Why? You look at E2 plus E4, this is 240, this is 40, right? 240, 40 kilowatt. That is this portion. How about that portion? 4 minus A. What is A? A is this. Do you get it? trouble, one stream must match the two hot streams or vice versa. Split it. In the process of splitting, you may create a temperature problem. That is the last of your worry. Okay, any problem with this? Okay, I got 8 minutes. 8 minutes. So, this is what you see on page 62, 63, okay? Page 63 is your final answer. Any question? So now, I give you the table for problem 3. What's going on? Okay. The answer is here. There's no pinch point. You only need steam. So here's a question. Do you put steam heater on all 3? Which one do you go with? I emphasize that today. You need to put a steam heater possibility 1, 2, 3 for your heater. What is this? Heat duty 935.75. Because your steam is the highest temperature, which one give you higher block temperature? 1, 2, 3. You favor that one. Okay? That's how you determine this heater location. Alright? Now, this problem, really, you go the way you want to match it, this way. Highest temperature hot stream, H1, right? Highest temperature cold stream, you match those two. Okay? Second highest temperature hot stream, second highest temperature. You can also go bottom up. Lowest temperature portion of hot stream, exchange heat with lowest temperature portion of hot stream. Second lowest temperature portion of cold stream, exchanging heat with second lowest temperature portion of hot stream. So get a piece of paper, top down, bottom up. That's how you try to determine hot and cold. I want you to practice doing this. I will assign another problem similar so you learn how to match hot and cold stream. Okay? Get a piece of paper, highest temperature portion of hot stream, highest temperature portion of cold stream. Put a changer there. Okay? So, I can take care of